Hey guys, it's Arca, and right now we're going to be doing a stoichiometry problem that starts with grams, molecules, and we're going to try and find the grams of iodine. Okay, so the first thing we need to do in a stoichiometry problem is balance our chemical reaction. Alright, so let's start with potassium. One potassium, one iodine, two iodines. We're going to need to change that. So we're going to put a 2 right here. So let's start again. 2 potassiums, 1 potassium. So we need to stick a 2 right there. 2 potassiums, 2 potassiums, 2 iodines, 2 chlorides, 2 chlorines, 2 chlorines. So our reaction's balanced. That's the first step. Okay. So now since we are given the mass of two reactants, we need to find the limiting reactant. If we're given the mass of just one reactant, that would be our limiting reactant. So we can't compare grams to molecules of chlorine, right? So we're going to have to convert this. We're going to have to convert its molecules of chlorine gas. So we're going to have to convert this to grams. So how are we going to start? How are we going to start getting this to grams? First, we should convert this to moles. A number should be popping into your head. Avogadro's number. For every mole of Cl2, there's 6.022 times 10 to the 23rd molecules of Cl2. Because a mole is 6.022 times 10 to the 23rd anything. A mole of eggs is 6.022 times 10 to the 23rd of eggs. Alright, so we're going to cancel out our units, molecules of Cl2. And then we can get our grams of Cl2 simply just using our molar mass. So we're going to put moles of Cl2 on the bottom. And then our grams of CO2 on the top. Cancel those out, cancel those out. So we get our units are grams of CO2. And that shall be 284 grams of CO2. Alright, so now that we found our grams of CO2, we can compare grams to find which one's a limiting reactant. So before we can even think about finding the grams of our product, iodine, we have to first find the limiting reactant. Which reactant will run out first, which therefore stops the reaction. So let's start with potassium iodide. We're going to find how much Cl2 will react with 85.6 grams of potassium iodide. So we're going to convert potassium iodide to moles, because moles are the gateway to finding everything you need. So for every 166 grams of potassium iodide, you get 1 mole of potassium iodide. So cancel out your units, grams of potassium iodide. Now that we have moles of potassium iodide, we're going to use a mole ratio, specifically a reactant to reactant mole ratio, which we use when we're trying to find the limiting reactant. So for every 2 moles of potassium iodide, we have 1 mole of Cl2. Alright, and then we're going to convert moles of Cl2 to grams of Cl2 using our molar mass, and that way we'll find the grams of Cl2 necessary to react to completion with 85.6 grams of potassium iodide. So that will be that shall be 18.3 grams of Cl2. Notice how this is 3 sig figs because this is 3 sig figs. Alright, so this is how much we need to completely react with 85.6 grams of potassium iodide. This is how much we need, but we have this much. So we have a lot more than we need. So that means Cl2 is in excess. Now, if Cl2 is in excess, that means that potassium iodide has to be limited. So we found a limiting reactant. Now that we found it, now we can go ahead and find the amount of iodine. So start with 85.6 grams of potassium iodide. And then we're gonna use our molar mass to get moles of potassium iodide. Molar mass of potassium iodide is 166 grams of potassium iodide per mole of potassium iodide. Grams cancel out. We're left with moles of potassium iodide. Then we're going to use our mole ratio. But note that our mole ratio is going to be a reactant to product mole ratio, since we're trying to find the mass of iodine solid. So for every 2 moles of potassium iodine, we're going to have 1 mole of iodine. And then to find the mass of iodine, all we have to do is use our molar mass to find the mass of iodine. And we want our u's to cancel out, so we're going to put moles on the bottom. And the molar mass of iodine is 253.8 grams per mole. Note that I had to double the molar mass of iodine by itself, because you have iodine solid, which is 2 iodine atoms put together. So once we plug this into the calculator, we get 65.4 grams of iodine solid. And that's your answer. That is how we do limiting reactant problems.